Today's learning target is I can write the prime factorization of composite numbers. To start with, let's take a look at prime numbers and composite numbers. So a prime number is a whole number that has exactly two factors. So for example, 2 is a prime number because the factors of 2 are 1 times 2. Okay, same with 3. 3 would be a prime number. There's only two factors that we can get to 3, 1 and 3. 5 would be another one. 13 would be one. 7 would be one. So prime numbers are any numbers where the only factor is 1 and itself. The only numbers you can multiply to get to it are 1 and itself. Okay. Composite numbers are numbers with more than two factors. So when we look at, for example, 4, okay, 4 has the factors 1 times 4 that we could get there, but we could also, 2 is also a factor because we could do 2 times 2. So that's what we call a composite number because it has more than two factors. In this case, 4 has 3 factors, 1, 2, and 4. 6 would be an example because 1 times 6 gets us to 6, and so does 2 times 3. So 1, 2, 3, and 6 are factors of 6. 8 would be a composite number. Let's see, 25 would be a composite number. We're going to be using prime and composite numbers when dealing with prime factorization today. What prime factorization is it's when we express a number as the product of all prime numbers. So basically saying, what prime numbers do you multiply to get to a specific number? Now to do prime factorization, we're going to do what's called a factor tree. I know some of you have called them factor fireworks before. Same thing. So let's show an example of this. Let's say we have the number 20, and we want to do the prime factorization of this. So what we do is we start off and we say, what are the factors of 20, or what two factors can we do to get to 20? Now I could do 2 times 10, I could do 5 times 4, doesn't matter, but I'm just going to start off with 2 times 10. Okay, now once we get to a prime number, we're just going to circle it. So 2 is prime, but 10 is not prime. 10 is composite. So I can break that down farther, and I can say that 10 would be 5 times 2. Now 2 is prime and 5 is prime. So I've now got the prime factorization finished for 20 because these are all prime numbers, and when I multiply 2 times 2 times 5, I get 20. 2 times 2 is 4, 4 times 5 is 20. So to show this as my final answer, I see that I have 2 times 2, but I know that that is 2 squared times 5. So this is how I would show the prime factorization for 20. In today's assignment, you're going to see the term monomial. And what a monomial is just a number or a variable that can be factored down into prime numbers. So to factor a number like this here, or a monomial like this, I'm going to start with the number here, 14. So we're going to factor this into two parts. The first part, like I said, will be 14. Now, to factor 14, I know that's going to be 2 times 7. Each of those is prime. So that is the factorization of 14. Now I have a to the third power here. So I know that a to the third power, or a cubed, is just, a cubed would just be a times a times a. So to factor this monomial, I would have 2 times 7 times a times a times a. And we don't use a to the third power, the exponent, because it's written that way here. So we actually just write it out like this. Okay. If I had something like 2 times 2 times a, then I would write that 2 squared times a times a. Now this one's going to be slightly different. You can see here I have a negative that I'm dealing with. So when doing this, first thing I want to do is I'm going to deal with this negative 9 first. So I have negative 9, and I want to factor this out. Now when dealing with a negative number, we want to get that as a positive. So here's how I can do that. I put negative 1 times 9. Okay, now that gives me, now I can factor out 9 as 3 times 3. So now when I take a look at this, there are my prime numbers that I'm dealing with. So I get negative 1 times 3 squared. Okay, and now I'm dealing with, I see there's one r, so I'm going to times by r, and then I see there are there are going to be 2 t's. So I would have times t times t. So this would be how I would factor that. So to get rid of that negative right here, you can see that in this factorization we have a negative 1 there. And you'll do it that way for any number, any negative number that you're trying to factor.